everyone, and thank you for joining us for our Data Science Master's Virtual Information Session. Before we get started, we have a few housekeeping tips. Please, your microphone is muted. If you have any questions, please type them in the Q&A window, and I'll address them to our panelists. If you have any non-general or personal specific questions, please email the Office of Graduate Admissions directly at graduateadmissions@site.edu. Roxana Witra, I am the Director of Graduate Admissions, and to have Dalva Couch with us is an Associate Professor in our Department of Computer Science. Professor Couch, can you please tell us a little bit about yourself and your research areas?
Well, currently I'm working in data management, which is a field very close to data science. I currently am the senior architect of a national data center for hydrologic information processing. We see freshwater science, and I'm actually, in some sense, the creator of the software for this. So I actually work directly with researchers in freshwater science to help them do their work, to help them make more reproducible results, and to help us verify their results and understand whether they can believe them or generalize them or do other things with them. Currently, we have major initiatives in flood prediction and in drought prediction.
And you started out at Tufts in the mathematics field, so how did you transition into computer science?
Well, it was a fairly easy transition at the time. A PhD advisor was an advisor in the math department. The field was applied mathematics. At the time, there was no such thing as a computer science degree. In fact, there was no such thing as a computer science degree in the U.S. at that time. So I had a PhD in mathematics with an emphasis upon applied mathematics and a thesis on visualization and parallel computing. When my advisor left Tufts, I actually, in a rather unusual turn of events, took a seat. Became the person in parallel computing and visualization in the department. So it was one of those things where that doesn't happen these days. That's something that happened in the early 80s, but does not happen these days, and it's very unusual. But for that reason, I've been here 30 years as a professor, and I have my 30-year medal to prove it.
Oh, that's fantastic. Well, Professor Couch, talking about data science, and this is a brand new master's program at Tufts University, but our faculty are not new to the field of data science. Can you tell us a little bit about why we decided to create this master's program at Tufts?
There was bottom-up demand. I'm having students come to my office saying, this is a really cool thing, I want to do it. Students started forming their own clubs around data science initiatives, most notably Tufts Enigma, which was a liberal arts club, and it's still running, to talk about issues of data science. And I was invited to one of their pizza parties to give, really that's what it is, to give them a talk on the basic findings of data science and hydrology and a little understanding of what data science was to me. Meanwhile, this engendered an ongoing conversation with many people. It turns out that engineering and data science are inextricably linked. I have found many initiatives that were going on before I even started to combine this program. There was already an initiative for data science and civil engineering. There was an initiative for several people in electrical engineering and several people in computer science. This program was actually developed as a result of looking at the total capability set of the engineering school as a whole, discovering a lot of data scientists hiding here, and then making a program out of the existing people. So it was actually a bottom-up process. I started with the bachelor's degree. That bachelor's degree is running now, and this fall we will be inaugurating the first class of the MS degree. So actually, the two degrees are very much linked, and they're very similar except for level. You will find that there are several courses that are very advanced that no undergraduate ever gets to, and that the master's students will get to because it's just easier for them in their standard programs. For people who don't know, the computer science department at Tufts is a mixed population program. It is very often that seniors and grad students will be in the same course. So we will have people in both programs actually in the same course, but looking toward different goals. In fact, the undergraduate degree has a senior project, master's degree has a master's project that is different.
Okay. You mentioned that it was a bottom-up approach, and you had data scientists hiding in civil and environmental engineering, electrical engineering. So can you talk about the interdisciplinary aspect of this degree program?
Well, I hate to use the word interdisciplinary because I cannot fulfill the university's definition of interdisciplinary, which is 3 or more departments and not belonging in any one department. I can justify the more general term of interdisciplinary, in the sense that every engineering discipline requires data analysis. It's as simple as that. And coming to the point where every engineering discipline doesn't just require data analysis in a traditional way via statistics, but the coming trends in data analysis, including machine learning. So there's a natural evolution toward data analysis and toward data science by engineering as a whole. Has motivated many people to say, me too. I expect that we will have new programs in data science and civil engineering that will segue with ours. We actually have these being planned now. That's because you can't really be a practicing civil engineer without knowing data analysis.
Right, that's very true. So, you mentioned data analytics. We do have a Master's in Data Analytics program that is also beginning here at Tufts. But in general, can you tell our audience what the difference, if there is a difference, between data science and data analytics?
There are 3 different things that I can comment upon. In cultures, data analytics and data science are synonyms. There's an implicit meaning that has come to be applied that data analytics is more general, data science is applied to business analytics. That is not actually true, but it is a culture. There's a third comment that I will make, that the fundamental difference between data analytics is between data analytics and data science, but between data analytics and so-called deep data science. Now, deep data science is different from data science in the sense that it is those techniques and problems that require neither a simple application, nor a simple application of machine learning, nor a simple application of statistics, but require a marriage of several concepts across the spectrum from statistics to machine learning. And there is a big difference between deep data science and data analytics. Data analytics tends to err on the side of more critical separation between machine learning and statistics, and deep data science puts them together. And there is no term deep analytics. I don't know why. I don't understand the actual terminologies. The terminologies are social and not technical. But the whole point of deep data science is a range of several things that are simply classical analysis or upcoming analysis. Examples of this include recommendation systems. For example, how Netflix figures out what movie you want to look at next. The second example I can give you is social network and trend analysis. How many people believe a certain thing? How many people, because of their tweets, have a specific opinion? As simple as how many people like Hondas, to a basic question, why do people like Hondas? And that in itself is not a simple matter of statistics or machine learning. It's a question that requires a marriage of concepts from both the parametric and non-parametric worlds.
Fascinating. I want to remind our audience that if you have questions for Dr. Alva Couch, please put them in the Q&A chat window, and I will have him answer your questions as we go through the information session. So let's turn a little bit to the program format. Can you tell us what the core requirements are for this program and what students enrolling can expect when they are a part of this program in the computer science department, electrical engineering?
There are 2 paths into the program. For people who have a lot of undergraduate math, describe the core of the program, which consists of an advanced course in statistics. It's if you have a course in statistics before this, called probabilistic systems analysis, and an advanced course in machine learning called Introduction to Machine Learning and Data Mining. The third course, Big Data, that is really unique to data science. That is the study of how you deal with planetary scale databases. Not simply databases that you keep on a computer, but things that might exist out in the internet that you have to analyze in some different way than you would normally analyze a piece of data that actually fits on your computer. It covers things like the MapReduce paradigm for parallel computing. Those are for the people who come in with a lot of math. People who don't come in with a lot of math, there are two bridge courses to help. There is a bridge course in advanced Python programming, which starts from scratch and gives you enough skill to get through the rest of the courses in Python. There is also a bridge course in linear algebra and applications of linear algebra for people who might not have had linear algebra in undergraduate school. The reason these courses exist is that we would like to admit Bachelor of Science students, and not all Bachelor of Science programs actually require either of these courses.
Bridge courses. Do you admit students, and we'll talk about the application process in a minute, but can students be admitted before they take these courses, or do you expect them to do the bridge courses and then apply?
I expect them to apply and then do the bridge courses. If you are a student in good standing in a science, if you've had a good academic record, have decent GREs, etc., then bridge courses occur after you have applied and been admitted. There is another path into the program. Mention it because it really is quite a matter of policy. If you have a record that is complete enough, you're not particularly proud of it, and you don't think you would be admitted, you can be admitted to the certificate, and we'll give you a chance to prove yourself. So I actually admit people in two different levels. People really outstanding undergraduate record can go directly into the MS. People who are less proud of their academic records can use their maturity. And you are fully cognizant of the fact that you might be a different person than you were when you were an undergraduate.
Absolutely.
So we give you the possibility of taking the certificate program first and proving yourself, and then basically erasing whatever things that you had before, because we will then know who you are. We have a good idea of who you are, and we can take into account your current performance instead of your past performance. And so the certificate is there for that particular validation. And by the way, folks, in case you are wondering what are not applied to this, I use this mechanism to get into grad school.
You did?
I used the mechanism to do. I became a part-time student first. I proved myself, and I got full-time admission. So you need to understand that you're talking to somebody who actually did this himself. So it's not a problem to do that.
Absolutely, and that's a good point. And a lot of our students do that. They do the certificate, and can they actually use those credits in the certificate towards their master's?
All of them.
Okay, so they can take all of the courses.
There's a new policy that was just instituted last year that says that now there is no rule. We have found no rule against actually awarding both the certificate and the master's. So when you get out from the certificate program, you can count everything. Courses. We have found there's no particular problem with us doing that. Checked into the academic rules, found that there was absolutely no problem with that. And so when you get out from the certificate program, you actually be awarded both the certificate and the MS.
Okay. We have a question from our audience. I see that the master's program can be completed in one academic year. Is that typically the case? Do people usually work or research while in the master's program? Well, this is a brand new program, but we can speak about the programs in general.
Well, I can answer that I am very much amenable to part-time students. Now, a part-time student cannot do the program in a single year. I have currently a pilot group of 3 part-time students I am admitting right now. They are exceptionally qualified, and they come from an unusual demographic. They're all professional software engineers, which means they don't need my bridge courses. So they're actually starting up now this spring, and they're going to be taking 1 course a term. Now, 1 course a term, the way it works out is 9 semesters. You take a course in the summer semester, you can complete the program in 3 calendar years. However, it's not unusual for people to do that. Here's the point. The class of person just wants to get it over with.
Right.
And the 1 year time is for them.
Mm-hmm.
However, there's also a class of person whose employer is paying for everything and doesn't want to get it over with.
Right.
Who wants to stretch out as far as they can.
Right.
And the net result of that is that there are a lot of part-time students in this program.
Mm-hmm.
For that reason, we try to offer courses at night.
Perfect.
We try to give people options that they can go to part-time.
Mm-hmm.
And a part-time student would take 3.5 years to finish this program.
Mm-hmm. And if they did it full-time, they can potentially finish in one year or one calendar year?
Calendar.
One calendar year.
Actually, if you really push it, you can finish in one academic year.
Mm-hmm.
But the truth of the matter is, if you look very carefully at the economics,
mm-hmm.
you realize that your residency is actually one academic year,
mm-hmm.
and that all you have to do is really pay a continuation fee to stay on another term,
right.
and most people do.
Yeah.
And so that's just because it's valuable. That has nothing to do with the degree.
Right.
It has to do with it being valuable. So we have absolutely no objection to that.
Yeah.
We're in any sense opposed to hanging out and
yeah.
doing something in the summer, or even taking on the summer and finishing it the next fall,
yeah.
which is okay with us too.
Absolutely.
So that's not a bad thing. And again, I expect that long term, roughly 1/2 of the students in this program will be part-time.
Mm-hmm. Mm-hmm.
To get an idea.
Absolutely.
And I'm admitting 3 right now.
So, into those that aren't fully ready to go to the master's program and they decide to do the certificate program, can they do the bridge courses in the certificate program?
Theoretically, they can.
Mm-hmm.
I have been actually putting people into the certificate program this
mm-hmm.
spring.
Mm-hmm.
But I will be putting people for fall admission, I will be bringing people in who can take those courses as part of the certificate.
Mm-hmm.
This spring, I'm not offering them yet.
Oh.
And so I am actually building the courses this spring. In fact, I'm taking off some time to build Comp 205
mm-hmm.
for data science.
Mm-hmm.
So I'll be teaching them.
Okay.
And I'll be teaching one of them. And it took me a little while to prepare the course. And I can't offer them to certificate students that are coming this spring. So the
mm-hmm.
certificate students that are coming this spring really do have to know how to program. They really do have to have some experience
mm-hmm.
in a high-level language.
Mm-hmm.
In the fall, they will be allowed to take them.
Okay.
And so, and actually, a lot of other populations have actually asked to be allowed to take them. So it may be a bit of a crowd.
So you apply now. Is exactly what
I'm saying that. Yeah, I'm saying that you can apply now.
Absolutely.
And it would be fine.
Mm-hmm.
And we will tell you, I don't know how we would do this, but we will tell you if we think you really need the bridge course
mm-hmm.
and that you should come in the fall rather than in the spring.
Right.
That's part of my job.
Okay.
Also, when you get here, you can have an appointment with me and customize your program. You don't need the bridge courses? Fine.
Yeah.
No problem. We'll do something else.
Absolutely. I think that speaks to the mentorship ability of our faculty.
Mm-hmm.
Dr. Ketch, can you talk to us a little bit about the elective courses
mm-hmm.
and what they have to include?
There are 3 categories of electives that you have to have at least one course from. The first category is data infrastructure.
Mm-hmm.
In other words, how does data get managed?
Mm-hmm.
There are a number of courses that are available in this, and they all concern things like how database systems work, how various internet systems work,
mm-hmm.
how cloud computing works, and what's the big deal about it?
Mm-hmm.
Why is cloud computing a big deal, etc. The second category is that of data analysis and visualization.
Mm-hmm.
In the category, it pretty much states what it is. Advanced courses in machine learning, advanced courses in statistics, data visualization.
Mm-hmm.
Also, we have some pioneers in data in visual analytics,
mm-hmm.
which is actually a new discipline, which is based upon the idea that you actually you reason from visualizations instead of reasoning from numbers.
Mm-hmm. Mm-hmm.
So that's the second category. Also in that category, there is human-computer interaction,
mm-hmm.
human factors. If you really want to go out on a limb, human-robot interaction, because we do have a course of that. There are a number of other things that we have courses in like that. Category 3 is theoretical underpinnings.
Mm-hmm.
But these courses are advanced statistics. For example, information theory,
mm-hmm.
a specific course in time series analysis, which is the core of modern data analysis, is
mm-hmm.
time series analysis, etc. Other courses in optimization,
mm-hmm.
So many of these courses are engineering courses as opposed to computer science courses. They actually don't overlap with the computer science curriculum at all. The fourth requirement for a master's student is either a project which applies all of your learning to some particular area, or a course in Category 4. Category 4 is applications and case studies. In other words, it's a course in which you're working on a very specific project and trying to understand how that project would use the techniques that you know. For example, I'm very well qualified to teach an applications course on water science. Other people know about other application domains. I have a professor who's a specialist in medical informatics, another one who's a specialist in environmental sustainability. Various case studies then study in order to do this. Now, many of these might end up being a final project instead of a course. I'm also looking at the case studies that are available in liberal arts, because there are a number of people in the sciences doing very interesting work. And they are interested, for example, in mentoring a case study in computational physics. Together.
Great.
So there are a number of different people involved. In fact, the program has over the years put in participation from about 15 departments.
Great. That's sick. We do have a question from our audience which relates to the project and the case studies. Are there any internship projects for this program where it is possible to work with real-time projects within the industry?
We have to have them. We don't have them right now. We are revising our internships and trying to revitalize them in computer science, and I have a meeting with the advisory board for computer science to talk about potential for internships in data science on February.
Great.
And so I'm working on it as the answer. We do not have it. It's a brand new program. Of course, we also know just how important it is. We have strategic alliances already with several businesses, and a number of people, including people on the engineering board of overseers, have said, send them to me, that they need this kind of reasoning, that they need this kind of training for their employees. So I think I'm going to be able to set something up, but I can't tell you anything until the end of spring.
Okay, that's good now. Now, speaking about the project, could the project also be a thesis, or are you thinking that people in this program won't necessarily do a thesis?
Thesis is not required.
Okay.
Theses are tolerated and encouraged. However, this program is fundamentally focused at people who want to make a career. And so as such, the thesis component is not something we play up. Would we allow people to do a thesis? We'd be overjoyed. We would not have any trouble with it at all. However, that's not the primary design of this program. Also, please note that we do not have, nor will we ever have, a PhD in data science. However, you can have a PhD in electrical engineering or computer science with a data science focus. And so if you wish to go on to a PhD, there are PhD programs that you could go into, and there's actually a PhD program in human-robot interaction as well. But that we don't call the PhD program data science. And there are PhD opportunities in several departments I can name that are actually based upon data science. This includes mathematics, civil engineering, electrical engineering, computer science, medical engineering, and so on, depending upon your project focus. So we're not actually trying to get PhD students through the program. We're actually trying to get people's lives and get people careers that they can use. And most of the people coming to the program would like a career change. I would speak just a small amount toward that. Data science is higher up in the management chain, computer science. And the reason is that people are actually going for data science right now is that they can get closer to management. We are talking with the Gordon Institute about having a management component, which is that it's possible that we would have a link between the Master of Science in Engineering, our very unique management degree for engineers, and the data science degree. People are really, the people who are going into this project want to change the world, and they realize that making decisions changes the world, and writing computer programs does not. So therefore, the program's not about writing computer programs. It's about making strategic decisions that financially sound, that make sense, that change the world, that bring new companies into existence, that develop new products, that find the magical balance between utility and cost. So many of those things that we're looking at are project-based. Many of the kind of things that we're looking at are entrepreneurial in nature.
Great. Let's go on to discussion about the application requirements. So just like all of our engineering master's programs, there is an application fee, the on application statement, your resume or CV, GPA scores, TOEFL scores if applicable, your undergraduate transcripts, and 3 letters of recommendation. So, Dr. Couch, we have a question from the audience. In case that the prospective candidate extensive and comprehensive work experience in a relevant IT field that ranges about 15 years, be considered for this program?
Yes. In fact, what we would do is the following. Depending upon how we can gauge that, we would either admit you to the main program if it looks like, well, okay, let me tell you what I want to do here, and I'll be very frank with you. I will admit you if I think you can succeed. If I'm not sure you can't succeed, I won't admit you because I don't like failing. I really don't like failing. However, a person with 15 years work experience and perhaps an academic record that's ancient history could go to the certificate. Right. It'd be a really easy way, and we could fast track you from the certificate into the data science MS. So that's when the certificate exists. It exists for people who have the qualifications but can't implement them. Right. And so the whole point of this is I will not admit you only under one condition: if I think you can succeed. Right. I'm going to be looking for evidence that you do science, that you do mathematics. They have at least a modicum of experience with these various things. In fact, I can't teach you science in this program. That's one of the reasons that I require a Bachelor of Science as opposed to a Bachelor of Arts. Okay. That's not a hard thing because some people give Bachelors of Arts in hard sciences. Right. If you have a Bachelor of Arts in physics, you're cool because there is such a thing. And give one out here. But if you have what is the equivalent of a Bachelor of Science, they start having the requirements. I can teach you science in a one-year program. I want you to have been in a lab. I want you to have collected data. I want you to know how to observe. And those are the things that you get from a nice undergraduate program in the sciences. I'm very flexible on that, and depending upon the rigor of it, I will social sciences as well.
Speaking of the undergraduates that may be listening in or planning to apply, and they have or they're earning a BA, what courses do you advise that they take in mathematics and sciences to prepare them for this if they don't want to do the certificate first?
Well, let me explain that the bridge courses are there because there are certain courses that people don't have. Those courses include Calculus 1, Calculus 2, multivariate calculus, and linear algebra 1. Those are the courses that I really want people to have before they get here. It would help to have a course in Introduction to Computer Science or Introduction to Programming. We don't expect you to become an expert at programming, and in fact, if you do, you'll have a second career. On the other hand, we don't expect that. That's not something that we're pushing for. We expect you to become an expert in writing non-reusable programs that, as a one-shot deal, prove that a specific course of action is appropriate. We should develop a product. We should not develop a product. We should name the product this versus that. Those are largely special effects of big data. It's the kind of experimental process that I would like. Now, if you have Introduction to Programming, Calculus 1, differential calculus, integral calculus, multivariate calculus, and linear algebra, you're taking the bridge courses.
Then who's the person that just asked the question? They may have taken it 15, 20 years ago. Do you suggest they get a refresher?
I suggest that you take it online massively. I suggest that you take an online massive course in that. Okay. Frankly, if you had it 15, 30 years ago, all you're going to need is to see the concepts again. You can actually get a decent course in each of these from edX. You pay something like $30. Okay. So if you feel that you want to come in and not have the bridge courses, which is fine, you can actually go and refresh yourself in an edX course, if you pay the $30 or $40, you can actually send me a certification. You can show me that you completed it. And that's one way of doing a refresher of something that might be ancient history. This is a very controversial thing. I'm not going to give you credit for it, but I can take it as evidence of your fitness to succeed, which is what I'm really looking for. And that's something that in general you can do also to test the waters. And specific recommendations and some courses that one could take to actually see whether you really want to do this degree or not.
Great. And if you'd like to ask Professor Couch what those are, you're welcome to email us at gradadmissions.edu. And Professor Alva Couch, we often get people on the road hung up on their GRE scores. They may have been in the industry for many years, or they are coming out of their undergraduate degree program and they have testing anxiety. How much weight do you put on their scores, even though we know it's a holistic process?
Let's put it this way. I weight on your math grades than on your math GREs. But your GREs, your personal expression GREs are pretty important to me. And it is really worrisome to me if someone has a low score on an English GRE. Just to give you a rough idea, I start having red flags go off if you're below 50th percentile in English. And the reason for that is you can't necessarily understand my lectures. It's going to be hard for you to keep up with me. If you have good grades in the appropriate courses, in ancient history, where you have the appropriate techniques to do this, and I know you can actually come back. You know, my attitude toward this is if you were a good student at one point, you can be a good student again. People unlearn how to be a good student. However, you have to deal with your background. And I can give a few recommendations on what to do before you come that can deal with your background. In the sense that all you really have to do is remember these concepts. For example, I wanted to come here without the bridge courses. You would want to know in the plane. Now, what I mean by that is, not all of multivariate calculus is really important, but one of the things we're going to do in E124, the probabilistic systems analysis course, is rather deep into what probability is as an integral. And we really do have to have some concept of multivariate integration. Now, absolutely everything in that course and all the weird little things about how to do particular integrals we really don't care about at all because we're going to do them numerically most of the time. But on the other hand, knowing that concept is the difference between success and failure in that course. Likewise, in linear algebra, you're going to be exposed to a lot of things again. The most important things that you can take from linear algebra in a data science course is data cleaning and reduction of dimension. Now, what I mean by that, being able to throw away things you don't need in a massive amount of data, and being able to figure out and concentrate upon the trends that are really valuable to you. What I mean by reduction of dimension is also often you've got too much data. You want to reduce the amount of data you have. And the way to do that is if you've got a bunch of columns, figure out which columns don't matter. We take from linear algebra because they are fairly simple applications of linear algebra. Make sense?
Absolutely. So we have a question from the audience, which is timely because I was about to ask you a similar question. What are the main distinctive features of our MS in data science at Tufts that usually distinguish it from other data science masters offered at other distinguished universities? We are a Tier 1 research university. I would like to point that out. But Professor Couch, tell us how ours stands out from
Well, what I will do is, instead of answering that question directly, I will point out that there are 3 different definitions of a data science program in this country right now. Number 1 is business intelligence. It doesn't go deep into the actual underpinnings of data. It does go into predictive behavior and trend analysis with that. Why? Because we go deeper into machine learning than they do. And we go deeper into the actual meaning of things and how not to lie to yourself with machine learning, which some programs actually don't cover that much. These techniques are not perfect. You have to be aware of their limits. The second definition of data science, which is statistics. We're neither. What's unique about us is that we fit in the third tier, which is a melding and equal components of statistics and machine learning and upcoming technologies. We say that when you're in this program, you will be applying very advanced things. But on the other hand, you'll also be studying in great detail how not to lie to yourself with these. It's a much deeper machine learning than you would actually get in a business decision-making process. It's not solely limited to advanced statistics. In fact, we will be having special topics courses on many parts of machine learning. We have, for example, you have to understand about our program that our program is actually centered around two different kinds of courses, the regular offerings and the special topics. We invite our faculty to talk about what's neat and cool about their research in a special topics course, and we also invite people from outside to offer special topics courses in their own research disciplines. So you can learn about natural processing. We have a natural language processing professor, but we do have someone online to teach it next term. I have, for example, a data science expert. We're looking for one, but we're looking for someone to teach data science. We do have experts in machine learning, statistical pattern recognition. The other one that's kind of hard to remember is areas of for sustainability, informatics for medicine. We have one person who does gene research. There's a course that you can take in that. There is a lot of interest in, and we have professors who teach, computer vision for robotics, which is in fact something you can take in this program. Of course. Yeah. I'm trying to remember the spring schedule, but the point of this is that it's a very dynamic curriculum. 150 level courses are offered once. And so we will have an opportunity for you to do something in a field that you might want to try out. I encourage you, when you see a 150 level course that intrigues you, to take it right then and there, because they're not necessarily repeated. And in fact, professors move on. They see something, for example, we have reinforcement learning this term, and that professor may not teach reinforcement learning for a while. He might teach something else. And he happens to be health and medics. So you probably wouldn't teach a course in that. You begin to see how this is very mobile. I call this an agile program, because every semester we try to bring in people with very special topics that they could use. We also allow transfer credit from other institutions. We have policies on that. I think it's 2 courses that you can transfer in. So if you see something really cool at MIT, you can take it. There are opportunities for transfer credit courses, anything we don't cover. Absolutely. I call it an agile program because it seems like it's very stable, and we actually designed the whole core of the program 3 years ago, but it is designed around change as a metaphor, which every term there are special topics courses that track what's happening. We have a very amusing course being offered next term, which is cybersecurity for future presidents. What should a president actually know about cybersecurity? So that gives you an idea of the level. Gives you an idea of the level of flexibility and the level of fluidity that exists in this program.
We have a prominent professor in cybersecurity working through the Fletcher School here at Tufts University.
We have
would our students be able to take their courses?
Be able to take very selected courses. I mean, security is something that a data scientist needs to know. Now, general policy, for example, foreign policy, is not something a general data science student needs to know. The rules on this are quite clear. I have to certify that the course is relevant to the program and actually say which category it fits into. Now, security is actually a topic in category 1, data infrastructure. So a security course actually counts. Yes. However, a course in foreign policy would count.
Right.
Now, the point is that there's no real limit against taking those courses if you're really interested, but they're not part of the degree program, and you'd be taking them as a special student.
Absolutely. We have a question from the audience, and they're asking, and I know the answer to this, but asking, how well would you say your program in data science pairs a BS in computer science?
They're programs. Let me compare it to my in computer science and give you a basic understanding of the difference. Now, first, I want to talk a little bit in very practical terms about 4 versus 1 year, and about hiring versus potential hiring, etc. Being in computer science makes you a software engineer, in essence. Now, whether or not we call it that, ours actually does, and our focus is systems programming and systems engineering, which is to say that most of our BS computer science people go to work at Microsoft on either Windows or Office, or to Google on their infrastructure there, or to other big companies, or there's something, or they start up. I characterize our program as a systems programming program in the sense that you learn to deal with complex interacting systems. And operating systems, writing Windows is a systems program, but Office is also a very complex program, and I consider that a systems program too. Now, data science is fundamentally different. It's different at the undergraduate level, and it's different at the graduate level. The difference is that the outcome of the program is not the ability to become a hell-bent-for-leather programmer. It has become a very effective analyst. That means is that your basic career is not writing programs, and programs are not the output of your programs are a vehicle of your work. For example, you're going to know how to write a really good program for figuring out what's going on Twitter. But that will not be your job. Your job will be figuring out what's going on Twitter. And then that's a fundamental difference here, in the sense that most data science programs are disposable. So we're doing very fancy ways of doing disposable programming very fast, answering complex questions very fast, and most importantly, not misusing the technology. Because frankly, many of the people who call themselves data scientists don't know limits of their methods, and many of them propose things that are just plain wrong because they don't understand the difference between these various algorithms. You cannot throw an arbitrary algorithm, arbitrary data. You have to know what you're doing.
We have another question from the audience. Since this MS program has started just recently, how frequent will there be curriculum changes? What are the related challenges and risks for attending such a brand new program?
Well, let's do it this way. We'll take care of you. At this point, I expect that there will be new courses, that we will be changing the curriculum a bit in the undergraduate program first. I believe at this point that the graduate program is stable. However, there is a risk to that, which is if anything new and hot comes, I need to be able to react to it. I may be a little slow at that, because right now I'm trying to hire a third machine learning person. I need someone in deep data science. I don't have someone in deep data science right now. The program risks are that we will not have something cool that we want to study, that there will not be an expert here. We're still building our expertise for this. Let me explain, however, that the system protects you very well. First of all, you can come here and graduate either with the requirements when you come or the requirements when you leave. It means that you have a flexibility of actually going with the old requirements if they suit your needs better. And so you should know that requirements only change every August. So you should understand that for each calendar year, for each academic year, the requirements are the same. At this point, I don't plan any major changes in this program for next year. I plan on any major changes for August. However, that being said, there is risk to that. If anything new cool comes up, and I can't find anybody to teach it, I'm going to be offering a course in it. We say that every school in the world has this problem. I'm necessarily going to be able to react with the agility that I think I need to react with dealing with some of these new things. I love to have somebody who knows about online voting.
Right.
I don't know anybody.
Right.
And for those of you who don't know me, I actually was a twister around the current conference on online voting. I actually got them to have the conference. So I was at the Unix Association at the time, and I was head arm twister to get the security experts in this country to come together and discuss online voting. So this is something that's very timely. I don't have a course in it. I have one this year.
Right, and I think I want to reiterate what you also said is across institutions. It's difficult to pull in a faculty member to teach hot topics quickly. So that's not just unique to our program at Tufts. That's across all institutions. Always risks for brand new programs.
Well, the biggest risk that I can tell you about right now is, first of all, I'm going to make sure you complete some way or other. If contingencies come up and I can't offer a required course, I will offer an alternative. But it's always going to be possible to get out of here. What I can't guarantee to you is that everything that evolves in the next year that's needed cool will be in our program. And that's the real problem I have. In fact, right now, what I really want to do is I really like someone who's an expert on recommendation systems to teach a course in it. So far, unsuccessful. And you understand that this market has an advantage and a disadvantage. We're in Boston. There are a ton of jobs here for this. There are also a ton of competing programs. It's hellishly difficult to hire a professor. Really hard to get a professor. So we are doing our best to get a third machine learning expert. So we hope that we will be able to cover something like that course in the immediate future, but we haven't even finished that search yet. We don't actually plan to put it on offer till April.
Now, you are the director of the program, and you spearheaded this program here at Tufts University, but who are the other faculty members that we can reach out to so you aren't fully inundated with all of the questions, so don't tax you constantly?
The active people who are involved in the program at some level are, on the science side, Kathleen Fisher and Lenore Cowan, and also our new machine learning people, Lee Pugh and Michael Hughes. On the electrical engineering side, we have a bunch of applied statisticians. And the main contacts there are Shuchen Aaron and Eric Miller. And I'm trying to remember, I unfortunately can't remember all the names right now.
Okay.
But I can get you a bunch of names that you could reach out to from there. And there are a bunch of applied statisticians there that you could reach out to other than me. Generally, Shuchen and I make every decision. Shuchen Aaron and I make every decision jointly. This is a joint program. It is actually the first program in engineering that sits between two departments instead of being housed in a department. It's new. That's a new concept. But you know, it's funny because when I created the program, the first time I presented it, people popped out of the woodwork and said, basically, that's me. I did this too. And so all of a sudden, I had a bunch of statisticians in the group, and I didn't have a bunch of statisticians in the group when I started. Very much colored the flavor of this program. The fact that I have a bunch of practicing statisticians who appeared basically out of nowhere the first time that I said anything about this program.
That's great. Question from our audience. Are there any data ethics courses available at Tufts? At the graduate level, of course.
We have a course in ethics for computing that is being offered the first time this summer, making a pilot of it. We have been discussing greatly the context of ethics in computer science. We have yet made it a formal part of the data science program. Now, what we have right now is that the people in the first school are helping us by offering Comp 55s and Comp 155s. These are special topics in the social context of computing. Social context means everything. It means ethics, but it also means social trends. It also means the impact of computing upon societies, etc. The first one of those is cybersecurity for future presidents, which is as much an ethics course as anything else.
Absolutely.
The feature of this, however, is that we would like to expand the Comp 155s and 50s to a lot of other topics. Meanwhile, faculty have gotten together and with absolutely no word from me, decided to put ethics in all their courses. So there's now a new move for ubiquitous ethics, at least one lecture in every course. So I'm not sure how this is going to shake out, to tell you the truth. I have no objection to either approach, but the ethics in every course thing is still being developed in the Comp 155 we've been working on for a few semesters.
So, Professor Couch, tell us a little bit about what you anticipate our graduates to go on to do in terms of work. It is a new program, but Tufts has plenty of graduates that do similar work. Can you talk about the companies they may go into? And we do have a career center that assists our graduates in getting positions and jobs. And our career center is life. You can as an alum, and you can also talk to our faculty. But Professor, can you tell us about the type of jobs our graduates go into?
Well, there are several different trajectories one can take. One trajectory is in industry management as an advisor to middle managers or upper-level managers. In other words, the manager will ask, what is the right strategic direction here? And you'll have to go off and take the data and do something with it. Likewise, there is a similar position in universities. A couple of students occupy that post right now, which is a data analyst for the university itself. They determine strategic trends that allow people to do better in the school. For example, they figure out what new programs that the university has to offer by looking at market research, by looking at student opinions and so on. They can also analyze which programs are successful. So that's one level of it, which is big business management. And one of the reasons we're thinking about combining this in some sense with the MSIM degree, Master of Science in Engineering Management, for that particular purpose. And actually, we're proposing that soon. It's going to be a dual master program. The other way that people go is to become entrepreneurs. I make you pretty dangerous with data, and that means that you'll be dangerous not only in a corporate setting, but if you're trying to start a business yourself. People who would either join with a startup and do analytics for a startup, of which there are essentially unlimited jobs right now, or become an entrepreneur yourself. So at this point, the people I have in the program are mostly going for the corporate ladder track, which is they would like to be an advisor to an upper-level manager with the possibility of moving into upper-level management. And that's really part of the reason that people do this, is that they'd like a management track. I'm expecting a number of these people to eventually enroll in MBAs. Now, if you know anything about an MBA, you realize it needs 5 years experience. And that's not something that you can just walk out of college and get. But you can get yourself in direct contact with managers by doing these skills. And so this is a nice ladder for people who would like to go up. That's part of the reason that most of the people who applied this time applied, which is into middle to upper management as an advisor in an advisory role to a job you might actually want, which is a level manager. So that gives you a bit of an understanding of the trajectory of this job right now. It is kaleidoscopically changing every year. It is rated one of the most desirable jobs in America. Why is that? Well, software engineering has gone down to number 2 or 3. Why is that? We're dealing with people and not dealing with cubicles. And so there's a basic attribute of the job which requires dealing with people and leads to a job that people like better than with a computer 24 hours a day. So that's really what people are thinking about when they're doing this job.
So I think that is a perfect answer to why people should be applying to our MS in data science. And I have one question before we have to wrap up. Will the MS data science at Tufts consider applicants who already have a master's degree?
Yes. We have plenty of people who have a master's degree in X and want a master's degree in Y. Now, understand that what we're trying to do is to give you an option for a new career. If your master's degree is too close to data science, we might just simply tell you, well, that doesn't seem like it's really going to help. If, on the other hand, you have a master's degree in software software engineering, which one of my applicants has, and want to go into this brand new field that has absolutely nothing to do with software engineering, then that's justified.
Right.
That's something you can do and something that you can get a credential from that you can spend. I'm going to tell you something else about the difference between data science and computer science, because exposure means a lot in computer science, but not in data science. I'm told by employers that they really won't accept a STEM MS in computer science because they want people to have the undergraduate program, because that means they've been working 4 years rather than 1.
Right.
Data science is not like that, because it's not a programming-centered discipline, reasoning-centered discipline. So your career faster.
Excellent. Thank you so much for joining us today. For those who logged in, thank you for joining us as well. You can contact us at the Office of Graduate Admissions at graduateadmissions@tufts.edu. Our phone number is also on the screen. If you have any questions for Professor Alva Couch, please email us. We'll relay your questions to him, and we look forward to receiving your application.